So now that we have bars and edges in V1, we can go upstairs a little bit to V2. And people do all sorts of work of looking at different types of patterns that cause different effects. And so some of them patterns were based upon like little gratings and shapes and swirls and things like that. And sometimes they were just on these types of edges and things. And it's by David Van Essen's lab, and they're very well-known neurophysiologist. But when you look at things like this, it's a little difficult to understand, exactly how this is moving upstream in the computational world. We understand the need for edges, and then you can maybe make some argument about circles or curved parts. One might say that, what I'm seeing is stuff that's maybe dealing with some types of intersections, or those kinds of things. But the neurophysiologists, they keep looking to understand what sorts of images or low-level features will cause cells to respond. Going upstairs even a little bit further, there's an area called the inferotemporal cortex, and Tanaka did a lot of work on looking at different kinds of features that seem to have cells that have a strong response to these and not other kinds of things. And the idea was that maybe these are where cells are starting to put things together, okay? And I guess one of the most well-known examples actually came, it was earlier, and the dates go different. There was this so-called hand neuron, okay? And what this was is this is a neuron that when you showed it a picture of a hand, it would fire a lot. And the front of a hand, the back of a hand. And remember, these are kind of like line drawings of hands, and even this one and that one, so different size scale. But what was interesting is if you had an image that just had these little spokes there, it doesn't look like a hand to me, doesn't look like a hand to you. Well, obviously, it didn't look like a hand to this cell either. And the idea that this was a cell. Now, you might wonder what this picture of this person looking like is. Well, there was this whole conversation of what was called, did we find the grandmother cell? That is, can you find a cell that just fires when it sees my grandmother? And I think this was just a play on that. But on the one hand, it was kind of cool that you would find a single cell that was responding to, say, just hands. On the other hand, we know for a lot of reasons that it can't be as simple as, there's a one-for-one mapping between concepts and cells, because there's all sorts of reasons why that would be a bad design. But we're getting at this idea that what's being processed is no longer just very simple features, but something like, this, which is obviously a collection of features in a useful way. To further point that out, here's two pictures of what you and I would say are approximately same-sized silhouette of a rhinoceros and a lion. And these look sort of similar in terms of where the stuff is, okay? But of course, they're different animals. And what's nice is that in V1, these trigger similar cells. So it's like cells that are responsible to the edges in this location, because the edges are sort of in the same spot. But of course, they respond differently in IT. IT is inferotemporal cortex. The idea is that maybe in the cortex is a cell that understands something about rhinoceros, so it won't respond when it sees a lion. And in fact, you can further confirm that by showing it, if you find a cell that sees lions but not rhinoceros, now you show it two different pictures. One that's a line drawing of a lion, and the other one a much smaller filled-in silhouette of a lion. These objects, in some sense, look different at the picture level, but they are the same thing. And unlike the previous pictures where they are different things but similar at the picture level, these respond very differently in V1, the early processing, and then there are the same in the inferotemporal cortex. So the idea being that higher up are cells in the vision system that understand something about the appearance of object types. At least that's sort of the story.